Hello guys, welcome to Solving Solutions on Brand channel where I get solutions to all your solving problems. It's 9th Avenue in class again today. How have you been? On today's tutorial, we are going to look at this traverse loop and then we'll see how to solve it. So in this loop, we have two controls at the beginning and then we have one control at the end, right? Good. And then in between, we have the distances and the external observed angles, right? So these are the information. For angle 1, you have this. For angle 2, for angle 3, angle 4, angle 5, and then angle 6, right? Good. And then for D1, well, you need to pay attention that D1 is actually what the distance between the two controls. So you are going to get that from a back computation. However, it was also given in the question, right? Good. So you are going to confirm yourself, right? Good. Maybe check yourself. Then D2, D3, D4, D5, D6, D7, right? Good. So there's something we did not see. We did not see having closed back on a control. We did not see that forward observation to another control that will help us to have a check, right? Good. So these are some observations. Now, the question is that, okay, and then the coordinates of the three controls we are given, right? Good. Of the two starting controls and then the one ending control. So the question is for us to compute the forward bearings in the loop. The forward bearings are actually CP1 to CP2, CP2 to A to B, B to C, C to D, and then let's say D to E, and then finally E to CP3, right? Good. And then compute the coordinates of all the points in the loop. Now we know CP1, CP2, and CP3, but we don't know from A to E. So we are going to compute what the coordinates of all of those points, right? Good. And then determine the linear misclosure at CP3. You know, by the time you get back to CP3 from your computation, you will not exactly get the coordinate given for or given to CP3, right? Good. So that is what the misclosure, right? Good. So these are the results, like an extract from the forward computation. So this is the forward computation. Now this is our arrangement of the controls. We have C3, C1, and C2. Reason being that if you come to the sketch, you can see that it's always easier this way anyway. You can decide to try it another way, but it's easier for you this way because if you look at the sketch, you can see that the traverse started from, or the control from which we started the traverse is CP2, right? Good. So it means you set on CP2, you back to CP3, to CP1 rather, and then you now forward to point 1, right? Good. So for you to be able to show this in your computation, your traverse computation easily, it will always be that you have what CP2 at the as the third control in your maybe set of controls, your set of 3 controls for your back computation. So that was why we chose to keep what 2 here, right? Good. So one could have asked, why is it not maybe 3 2 1 or maybe 1 2 3, right? Good. So that's why our 2 is here. So if we have 3 1 2, then it will now be from 3 to 1 and then from 1 to what to 2, right? Good. So you know how to carry out your back computation. So we saw this emulator, which has been very fantastic for us. So you have the order of operation is always the second one minus the first one, the third one minus the second one, right? Good. So let's do for just a few. So we have 534 290.899, then minus 534 437.796, right? Good. So this should give you the delta. Okay, there was something I typed in error. This is supposed to be 290.889, right? Good. So this is supposed to be 889. Good. So you have what? Minus 146.907. That's for your first delta nothing. If you want to also get the second delta nothing, it will still be what? So now this is in math. So we just click on this. You have what 19.365, right? Good. So let's see if we can modify this to line, and then let's also take this to 3 decimal places, right? Good. So we have 6 and then 3. So our last answer should be 16.365, 19.365. So you do similar stuff for what? For your easting to get your delta easting. Then finally, when we want to now get the distances and the bearings between what? The controls, it will now be shift pole, right? Good. And then our input will be delta notens, comma, delta easting. So our delta notens is what? Minus 146.907. Then comma, that's shift this. And then our delta easting is what? Minus 302.210. So this returns the distance. So alpha y, or let's say alpha x first, that's for your distance, that's 336.025, and then alpha y degrees, so let's add that is negative, right? Good. So what we are going to do is that we are going to add 360 degrees to it, so that we can now get the equivalent bearing of that line, which is what 244 degrees 4 minute 30.37. So this is how you get what? The distance and bearing between your controls, right? Good. Now when you have done that, the next thing is the second line, just like we have done. You still what start by saying pole, right? Good. So that should be shift plus, right? Good. And then you impute your delta notens, comma, your delta eastings. So it will give you this bearing and this distance. Now what we have told you earlier is that if you set on CP2, you can back to CP1 and then forward to control A. Therefore, when you now get to CP2 here, you back to CP1 before ever you forward to control A. Therefore, your back bearing at this CP2 will be what? The back bearing from what? 1 to 2. So you add what? 180 to what? To 62. So when you add 180 to 62, you definitely have what? 242, right? Good. So that's why the back bearing at this point is 242, because in every, let's say at every station, right, you have your back bearing, your observed angle, and then your forward bearing. Your back bearing, your observed angle, and your forward bearing. So that is what the order. So since we have been able to establish that from CP1 to CP2 is 62, then from CP2 to CP1 as a back bearing, which is what we have here, will be what? 62 plus 180, right? Good. So that's this. Then these are the observed angles. So the observed angle we have at CP1, or at CP2 rather, is 176 2019. So we have 176 degree 2019. So if you add through, okay, so let's have this one. So we have what? The distance and the bearing. However, we are more interested in the bearing, so we have y degrees to be 62. So plus 180. So we have this. Now if we now add the 176 to it, so it will be plus 176 degrees 20 minutes and then 19 seconds, right? See, the value is more than 360, so we have to subtract 360 degrees from it, right? Good. So it now gives us the equivalent forward bearing at that particular line, right? Good. So that was how we did. So since this is 58, remember what we did there? We had 62, right? Good. So if the forward bearing is this, then the back bearing will be what? Plus 180, because it is less than 180. So we still add 180 to this. It will be plus 180 degrees. That will give you what? 238, 31, 23. Then you add what? The next observed angle. So you populate it until you get to what? You get to E. By the time you get to E, you would have gotten what? Your forward bearing, right? Good. Then you now come back to the next data you have, which is what? The distances, right? Good. Now we told you that we are going to have a check. Now D1, which is what? The distance between CP2 and CP1 from our back computation, is still what? 41.50, and then from the question it is also 41.50. So that gives you maybe a check to know that the distance given and then the distance you computed are actually the same for this particular line, reason being that it's what? A fixed line, right? Good. So now we have to populate the traverse computation sheet with what the distance is. So this is fixed, we don't need it. So we start from D2. So D2 is what? 48.1. So you populate it 48.1, 54.3, 62.33 down to the last distance, right? Good. So having done that, we now need what? Our delta nothings and delta icing, because the next part of the question, we have actually gotten all our forward bearings. So these are the forward bearings as we have what? Extracted them. One thing to note is that we told you earlier that having closed on, let's minimize this, having closed on CP3, we did not see the observation from CP3 to either CP2 or CP1 as the case may be. That will now help us to have that check, the angular check for our traverse, right? Good. On this our closing line. So we just have to stop at CP3 as the question has provided, right? Good. So if maybe the question went further to, in our loop, say from CP3 to CP1 or maybe CP2, we will now have what? From CP3 to what? To CP1 or CP2, and then that line will now be the line to what? To check our traverse, right? Good. So since it's not there, let's move on. So these are the forward bearings from our computation. The next is what? The coordinates of all points. So we are trying to explain that since you have your forward bearings and then you have populated the distances, you can now use your distance and bearing to get what? Your delta nothings and what? Your delta hastings, right? Good. Remember when we are coming from the back computation column, we use our delta nothings and our delta hastings to get our distance and bearing. However, we now want to use the distance and bearing this time around, that's distance and bearing, to get what? The delta nothings and delta hastings, which will now be used with the coordinates of the starting control to get the coordinates of what? The subsequent points, right? Good. So to achieve that, we still come back to our calculator. Remember at first we used what? We used pole, right? Good. However, we are going to use rectangle, so it will now be shift minus, right? Good. And then our input will be distance comma bearing. So the distance is what? For the first line we have 48.1, then comma, we have a bearing of 58 degrees, 31 minutes, 23.39 seconds, right? Good. So we have what? The delta nothings and delta hastings displayed, right? Good. So if we decide to maybe take it to x, sorry, supposed to be alpha x equal to, this gives you the delta nothings value. Similarly, alpha y, this gives you what? The delta hasting value. So this is how you use to what? To get the delta nothings and delta hastings of all of the lines, right? Good. Using the rec. The order is what? Distance comma bearing. Using rec. The first value that is being displayed is your delta nothings. The second value is what? Your delta hastings, right? Good. So having populated it down, we now have to use the coordinate of the starting control, which is what? CP2. And then if we also look at the sketch, we can see CP2 here, right? Good. So the coordinate of the starting control, which is CP2, alongside the delta nothings and delta hastings, to now get the coordinates of what? The subsequent point. So if we start from here, which is say 534,310.254, right? Good. And then the next delta nothings is what? Plus 25.116. So it has given you the coordinate of the next point, right? Good. Which is control A. So you do similar thing. This control, this coordinate rather, plus or minus what? Delta nothing. So this value can be positive, it can be negative. That's why you can see plus or minus somewhere around there, right? Good. So it now be this same value, no longer the value of the first control, but that of the next point you've gotten, plus 25.918. That gives you this, right? So that's how you drag it until you get to this point. Now when you get to this point, you now compare the coordinate that you would have computed with or to the coordinate that is given, because CP3 is a known point, is a control, right? Good. So since it is a control, the value is given, That's this value in red. So you now compare these two values. When you compare these two values, whatever difference you have is what the misclosure, and that is the third part of the task, right? Good. So the second part and the third part are actually together. In fact, they are all together, including the first part. So the second part and the third part are actually together. So when you now get to your closing control, comparing the values by using the computed and the given gives you what your misclosure. So let's just start that of the listing as well. So we have 271,038.957, right? Good. And then we have plus 41.022. So that gives us 271,079.979. So you do this plus 47.715. That gives you 271,127.694. Plus this, it will give you this, plus this, it will give you this, plus this, it will give you this. This plus this is now finally this, right? Good. So that will now be compared with the coordinates of CP3 as provided earlier. So the difference is what your misclosure. Now before we leave, you can see that the signs are different. There is a very easy way we use to explain the sign. Now you have been given a value, the value that you are working towards. That's the value you are supposed to achieve. However, when you were computing, you achieved a different value. So how do you know the sign to attach or to assign, right? Good. How do you know the sign to assign each of those misclosure values? You compare them. Now you were given a value. Let's look at the last two numbers or two digits before the decimal. We have 37.564, and then what you are given is actually 37.796. You know that 37.564 is smaller than 37.796 because 564 is smaller than what 796. The values from the whole numbers are actually equal. 3737 is the decimal that there's a difference, and then from the decimal you can see that 561 is smaller than 796, which means you need to add to 561 to get to 796. Therefore your sign here will be positive. That's a very easy way to know. Then coming down to this point, the whole numbers are still the same. So now let's concentrate on what the decimal. So we have 0.523 and then we have what 0.462. Now 0.523 is bigger in this instance than 0.462. Therefore you need to remove from 0.523 to get to 0.462. This now implies that your misclosure, the sign for your misclosure will be what will be negative. So if you approach it in this manner, you will not have any issue with knowing the sign, because the signs are very important. You will not have any issue with knowing the signs to assign to each of the misclosure values, right? Good, because -1 is not the same thing as +1. Minus this is not the same thing as plus this, and then minus this is not the same thing as plus this, right? Good. So having established all of those facts, it then means that we have completed the task that is required of us. We have computed the fault bearings which we have here, and then we have also computed the coordinates. Now we wanted to write the coordinates in red conventionally. However, we noted that we discovered, or we later realized, we later realized that since no corrections were applied, there is no need for us to have the coordinates in red. So we just had to cross it and then continue with black, right? Good. So they are not corrected coordinates. They are just coordinates of, just don't want to call them uncorrected. They are just coordinates of the points, right? Good. So there was no room for applying correction yet. So we just have to leave it that way. So we proceeded to extracting the values, that of A, that of B, that of C down to A. Then the misclosure, as we have explained, you extract these two values alongside their sign. So that's what you have here, right? Good. So we now went further to do the linear misclosure, right? Good. So which is 1 over the square root of delta nothing squared plus delta SN squared, all divided by your total distance, right? Good. So we discovered that our total distance is for 305.150, and then this is gotten from, or this gotten by adding all of these distances from 48.1 down to 21.88. So if you add all of these values down to this point, you should be able to arrive at this 305.150 meters, right? Good. So we now use this to get the linear accuracy, which is actually very, very not too good, right? Good. Now there are a few notes here for if you want to use the conventional method, because sometimes they would want you to show working in quote, right? Good. So for you to get your delta nothings is actually L cos theta, and then for you to get your delta hastings is what? L sin theta, and then your distance is equal to the square root of what? Delta nothing squared plus delta hastings squared, and then for bearing it's tan inverse of delta hasting over delta nothings. However, there is still something to note, that you need to know the quadrants each of those values fall, so that you know the value to add to them, right? Good. So that's all about using these formula that we have noted. So thanks for coming to class. We hope we have exhaustively and painstakingly explained all of this to you, and then we believe that all your questions are actually answered. However, you can still reach out to us if you have any problem like this. We'll then be glad to help you solve them. So until we see you on the next tutorial, ensure you keep staying safe and have a very good time. Bye.